Hi, I want to take you through one of my favorite tools for building containers and testing source code quickly. Software to image, or s2i, is a great underutilized tool that I think it can really help developers in the inner loop development process. Now, if you're not familiar with the inner loop development process, it is an iterative process of writing, building, and debugging code that a single developer typically performs before moving that code into some kind of SCM, such as GitLab or GitHub. And there are a lot of challenges around the inner loop. Number one, the need to move quickly. And how do you remain productive if you're waiting on your continuous integration processes to run? And we've seen in the last, say, 5 to 8 years, a big shift in development to cloud native microservices that are deployed to scale out systems such as Kubernetes. And that means managing dependencies such as Docker files and YAML configuration files. And while the move to containerized microservices is great, and it's a big shift, and it offers a tremendous amount of benefits, in some cases it can actually slow the development loop, and developers might spend less time coding and more time managing these configuration files. And here's a very nice graphic that I think kind of sums up the inner loop development process. This is from Jason Dudash at Red Hat. And as you can see in the center, there is the inner loop that eventually moves to the outer loop or to development staging. Now, the shift to containers can certainly help in the inner loop development process. In the past, developers might have tested and developed against some kind of virtual machine that may have matched what the application might run on in production. But now with containers, we've kind of slimmed that process down where the container only runs the binaries and libraries that are necessary to actually run the actual application. And there are all kinds of benefits, great benefits to containers, such as less overhead with CPU and memory, and because you don't have to run the entire operating system. It's just, again, the libraries and binaries that need to run the application. There's of course an aspect of portability because you can deploy these containers to multiple types of operating system. Maybe on a laptop you're using Mac OS or Windows or Linux, and that container should run the same across those different environments. And as you might imagine, then of course that provides consistency, that the application should run the same regardless of environment. And I mean mostly the same. I'm not talking about actual performance where performance between machines and whatnot might vary, but the application functions should by and large run mostly the same. And that of course will bring out a greater amount of efficiency because those applications can be deployed patched and scaled much more easily. And really at the end, it's all about better application development. Containers are inherently agile, and that helps the DevOps teams accelerate the development, testing, and production cycles. However, what about security? This is often overlooked by developers and development teams, especially when it comes down to multi-tenant environments where you're going to have more than one application running, and you need to make sure that one application can affect the other. And what about those libraries in the app? Are they up to date? Do they address the latest security concerns? If you've ever developed in Python or Node.js, you know that you need to update those dependencies frequently to address CVEs and whatnot. And What about manageability? If you're really the end goal is like you just want to test your application source code and ensure that it's running, do you really want to or need to build and maintain Docker files? And then of course there's performance and monitoring. How well do you see? How do you actually see how well your application is going to perform? You know, it might be one thing to develop locally, and you got that beefy laptop that's maybe not doing much, or maybe you got a browser with 32 something tabs, you know, or something like that open, and you're not really going to get a lot of insight into the performance there. So that brings us to s2i, software to image. This is an open source project sponsored by Red Hat that has the following goal. It is a tool for building reproducible container images by injecting the source code into a container image and assembling that container for the end user, and it allows incremental building of containers by reusing previously downloaded dependencies and artifacts and whatnot. And one of my favorite features of the s2i tool is that it auto detects runtimes. I'll demonstrate this here in a few minutes. But s2i can detect that source code and make a suggestion. You can use it or not. Such as, hey, this is a Python app, this is a Java app, it's a Node app, Go, maybe PHP, something like that, and it will give you a proper container baseline for that application's dependency. Secondly, and this is huge, of course, as we're talking about speeding up the inner loop development process, that s2i can perform a huge number of complex operations without creating a new container layer at each step, and that results in a fast iterative process. And that's really great because you can see right away if your application is working. And then of course patchability, going back to the security concerns in terms of like updating the container runtime to make sure that it's using the latest and greatest libraries for the application. You can quickly patch that container, and then of course test it to make sure that the application is running correctly after the patch. And also operational security. You got to worry about root privilege escalation with containers, especially in a multi-tenant environment. And s2i restricts the operations performed as the root user and ensures that scripts can be run as a non-root user. So with that, let's get started. And I will post the instructions on GitHub so that you can follow along. All right, so I'm going to use my single node OpenShift instance to test out the s2i tool because s2i comes with OpenShift. And so I'm going to create a new project here. I'm going to call it Chat. This is a chat app because that's where the money's at these days. That's what my kids tell me. And I'm going to switch to the developer view here, and I'm going to add a container to this, and I'm going to build it from a GitHub or Git source repository. There we go, chat, and yes, it detected that my great chat app is a Node.js app, and it's going to build it off the universal base image. I'm going to scroll through some of these options here, keeping most of the defaults. I'm going to select the deployment config because I might change some options later. I am going to skip adding a pipeline for right now. OpenShift automatically creates a route for me, and it creates a secure route so that my great chat app can be accessed securely, and it will redirect all traffic to HTTPS. Click on add. Now it's going to start the build process. I can click on that little icon there, and it will take me to the logs, and look at that. It's building the container image for me based on the source. We can watch the magic happen. Should go through pretty quickly. And we're almost done. Look at that. The push was successful. Now if I click back on the topology view, you'll see that the container is now finished. It's a solid blue. I can click on the URL, and there is my first chat app. Okay, so let's add a webhook. If you're not familiar with a webhook, it is a type of integration with a service such as GitLab or GitHub that allows you to subscribe to certain events. In this case, when I push new source code, we want a webhook to tell OpenShift to rebuild a container, or I should say s2i. So yeah, let's do some of this from the command line here. So I'm going to need my API token, and let's display that there. All right, I'm going to copy that and then put that in the terminal. Great, I have logged in. Let me run oc get pods. Great, I've got one instance running. Now I need to run or obtain the build configuration for my project here, and a build configuration describes the strategy that you're using for your projects here. So let me describe the build config for my project using oc describe bc chat. Okay, that's great. Yep, I'm building as you can see, my strategy is from source code, and I'm going to copy the GitHub specific webhook URL there. OpenShift provides two. One is generic that you can use with other source code management systems here, but I want GitHub. So I'm going to go over to my GitHub project page, click on settings, and I will scroll down to webhooks. And I'm going to add a webhook. And GitHub wants me to verify that I am who I say I am. Okay, great. So I will paste that URL from OpenShift into the payload URL. I need to change the content type to application JSON. And then I need the secret, so I will go over to the developer console here, click on secrets, scroll to the GitHub specific webhook secret, and I will copy that to the clipboard, go back to GitHub, and I will replace that little placeholder there with the contents from my clipboard. There it is. Okay, and now I need to disable SSL verification here. There's something strange going on between GitHub and Let's Encrypt certificates. I don't understand why. GitHub, Let's Encrypt is a global CA, but it's not working great, so I'm just going to disable verification here, but it is still sent securely. Okay, there we go. So I have a green check mark, which means that the webhook can successfully communicate to my project running inside of OpenShift. So let's make a code change. Okay, so let's change our source code to trigger a webhook, which will in turn tell s2i to rebuild the container. All right, so I'm going to open up the source code in Vim, and I'll make a few small changes here. And yeah, let's change out that smiley. We'll make a comment. I'm going to change the name of my great app. We'll call it Deep Purple. That sounds pretty good. All right, let's commit that change to the file. And then let's commit it to Git. And we'll say we are making changes to name. Yep, I think that's accurate enough. And let's push it to our repo. Okay, and look at that. So almost instantaneously, the webhook from GitHub is triggering s2i to rebuild the container for us. As I mentioned earlier, the subsequent changes should happen a lot faster because those changes, most of the artifacts are already cached locally. So we're only doing a few changes, and the rebuild should happen pretty quickly here. You can see there in step 8 of 9 that the s2i assemble process has been kicked off, and we're resolving any dependencies. It's also not running as root, which is great. And I'll kick back over to the topology view, and look at that. The container was rebuilt. Oh, looks like the browser is caching the old version, so Let me tell it to refresh. Might take a second or two here. And there we go. All right, there's our change. Okay, so that concludes the demo. I appreciate you watching, and I hope you found this useful, and please leave me any comments. Thank you.